Okay, start. So, good afternoon class. Today we'll be looking at physical quantities, units and measurement. So, to give you an idea of what you'll be looking at, I have these two diagrams. So, the first one is what we call a vernier caliper, second one is micrometer screw gauge. So, these two instruments, you'll be looking at them at the end of the lesson and you will need to know when to use them. So, first one, let's start with this activity. So you all have a 30 cm ruler. So I want you all to use this ruler and find the length of the laboratory desk and then the diameter of the mouth of the boiling tube and also the thickness of an A4 paper. So I give you 1 minute for that. Just measure and tell me what value you get. Okay, 1 minute, just hurry up then. Okay, I think you all done. Timothy, can you tell me what value do you get for the length of the...
The length of the desk is 148.5 cm.
Okay, 148.5 cm. Chandra, what do you get?
150.
150 cm.
0.5.
Okay, 150.5 cm. So, Wei-Lin, can you tell me why is there such a difference, 2 cm difference?
Maybe it's the way they measure it.
Okay, so how do you measure it?
We try to basically make sure that ruler, we put a point on the table. Yeah, and make sure that we there is no zero error and we are very focused on the measurement. Yeah.
Okay, I haven't taught you zero error yet, so later on I will go through that with you. Maybe you learn that in tuition. And any difficulty that you encountered in doing this activity? Yeah.
Because when we measure the dash, the ruler is not long.
Right. Okay, so the ruler is not long enough, so this is the first thing that you've noticed. You can't measure the length of the desk in one shot. So let's move on to the diameter of the mouth of the boiling tube. So Kenneth, what do you get?
I think
2.5 cm. Okay, did anyone get a different value?
Yeah.
What do you get, Timothy?
I get
3 cm.
3.2.
3.2 cm. Wow, such a big difference.
Yeah.
Okay, can you show me how you measure?
So I put the ruler like that. So it's 3.2.
I see. Okay. Yes, so you realize that the difference is 0.7 cm. So, okay, what can you tell me about, okay, I'll go on to that later on. Let's just talk about the thickness of the paper. So what's the thickness? And then what do you get?
0.
0 cm. Wherein, what can you comment about this answer? 0 cm thickness of the paper.
maybe it's too thin that the measurement tool cannot capture the exact thickness.
Yeah, so Alan, can you comment on your own answer? Is it possible to have thickness to be 0 cm?
Yeah, that would be so.
Exactly. So it means that the thickness is too small for you to be able to use the ruler to measure it. That's why before you tell me 0 cm, you should think. If it's 0 cm means you don't even have a paper there. So okay, check whether your answer is available. So okay, let's move on to those questions. So one practical limitation of using the ruler to measure the diameter of the mouth of the boiling tube. So this is why you have this difference of 0.7 cm. Just now when Timothy showed me how he measured to get 3.2 cm. So let me show you what he did. Okay, let's say this is the mouth of the boiling tube. Okay, he placed the ruler here. So he told me that this is 3.2 cm. Chandra, what can you say about this?
From where to where?
From here to here.
Yeah, but the mouth and the body is about different diameter, right?
Exactly. So how do you know whether this is the diameter? Right? So even though the cross section is a circle, you don't know where's the center of the circle, so you cannot measure the diameter exactly. That's why you have this practical limitation. Okay, so you use your ruler and you place it across the mouth of the boiling tube. Okay, you don't know whether you're passing through the center, so you don't know whether you're measuring the diameter. So this is one practical limitation. Second one, okay, how do you get a more precise value for the thickness of the paper? So just now, okay, we have seen that you get 0 cm, you get a very small value, but what can you do using the ruler itself? How can you get a more precise value for the thickness? Can I have any idea?
Maybe we can like measure a stack of paper.
Alright,
Then
okay,
divide.
so you measure, okay, for example 20 pages and then you find the average. Still, by using the ruler, you should get a fairly accurate value and then you divide by 20, you will get the thickness of one sheet. Okay, so let's do a quick recap on what you will need for this chapter. So 1 meter is equal to how many cm is equal to how many mm? Timothy?
1 meter is equals to 100 cm.
Correct. And how many millimeters?
1000 millimeters.
Yes, this is straightforward. Okay, it's just to refresh your memory. And possible errors that you can get when using a ruler to do measurements. Wei Lin, just now you mentioned
Just now I mentioned zero error.
zero error. Can you elaborate on this?
Okay, so for example, zero error. Sorry, parallax error. Okay, so for example, I look at it at an angle, then
Okay.
I might not read the correct reading.
Okay, so again, you're mentioning zero error and parallax error, but I haven't taught you yet, so be careful. You might confuse your classmates. So the first one that sometimes students do, they will not start from the zero mark. So if let's say this is the length of the line that you want to measure, let's say I place my ruler here. Okay, so this is the line. Okay, instead of starting at, let's say the zero is here, instead of starting at 0, I'm starting at 1, and then I end up with 15. So students might say, okay, the length of the line is 15 cm, which is wrong because you didn't start at 0, you started at 1. So the correct value here, Chandra, should be
16?
you're starting at 1, but you're ending at 15.
Okay, 14 then.
14. Okay, be careful. Because you're starting at 1 means that the value that you get is actually longer than what it should be. So you must take the difference, 15 minus 1. So 14. So this is what we call an end error. And then the second part, okay, it's not directly facing the scale, is what Wei Lin mentioned. So let's say I have, okay, the ruler like this. My marking is here. Let's say 15 cm. Instead of placing my eye here, okay, let's say if I put it, okay, from this side, I look, okay, you won't really get 15. You will get 15.1, let's say, because you're looking at an angle. Similarly, from this side, you might not see 15. You can get, let's say, 14.9. So this is what we call parallax error. So be careful about this. You must always look directly across the marking. Okay, so examples of errors. So I'll just go through this quickly because we've seen it. Okay, zero error is when the needle and or the pointer is not, okay, at the 0 mark. So it's a bit related to the ruler, the end error that we have seen here. So you're not starting at 0. So this picture shows you this ammeter that when you're not connecting anything, it is not at 0. It is before 0. So your value will be wrong. Okay, so you can relate this to your weighing scale in the bathroom also. So let's say you're not standing on it, but it's showing you 0.1 kg. So you know already that the value that you will get will be wrong. Okay, second one is end error, like I've shown you on the whiteboard here. Okay, when you don't place it when you don't start at a 0 mark. So here I'm starting at 2, and then the value that I get 5 is not the correct one. You must take 5 minus 2. You must do this adjustment. And then the last one is parallax error. So here the diagram shows you how it's applied to measuring the volume, okay, from a measuring cylinder. So it must always be opposite the marking to be red. And then for the second one here, you can see that you have this strip of mirror in this apparatus. Timothy, any idea why you have this strip of mirror? What's the purpose? Okay, it's not for you to check your haircut or...
Maybe it's very dim, then you need light, you just shine light on it, then you can reflect light.
Okay, that's a very innovative answer. And then what do you think?
No correct.
No. Okay, remember that we're talking about parallax error here. So how does this mirror, yeah?
Since you're talking about parallax error here, so the thing will correct parallax error.
Okay, can you elaborate on this?
And
Wayne, did your tuition teacher mention to you this?
No, let it be on MC.
Okay. So you can see that the mirror is actually helping you to make sure that you're directly facing the marking to be red. So let's say if you're looking from an angle, you will see the reflection of the pointer in the mirror. It's only when you're facing it directly perpendicular to it, then you won't see the reflection. So it means that they are one behind the other. So that's why you will eliminate the parallax error. So don't worry, we'll have a look at this when we do the practical experiments. Okay, now these 4 types of errors. Okay, I'd like to tell you that it's not really in your O-level syllabus, but since you are high ability learners and it's good for you to know this difference between systematic and random error, so I'll touch on that. Okay, first one, systematic error. You can see you have this plus and minus symbol in the heading there. Whereas for the random one, it's plus minus together. So what's the difference? Okay, systematic error, the measured value is either always larger or always smaller. This is why the plus and the minus are separate from each other. So what's the reason for that? It's because of the apparatus or the observer. So it can be one of these 2 factors. So examples would be the 0 error and end error that we have seen just now. So you can see here for the end error, 15 cm. So if let's say I start at 2, so if I'm using the same line, so this value here should be 16, right? 16 cm. So to make the adjustment, I will need to subtract 2 from 16. So I will still get 14 cm. Here also the correct value is 14 cm. But what you notice in these 2 cases, the value that you read is always bigger than the exact one. So the exact one is 14, but you get 15 and 16. This is what we call a systematic error. It will always be greater than the one that you are supposed to get. This is why it's always plus, systematic error. And the last one, if you have a stopwatch which is running too fast or too slow, so again, it's a systematic error. So this is due to the instrument itself. Okay, instead of going at the normal pace, if it goes too slow, so the reading that you will get is smaller than what it should be. Okay, so random error, perfect example would be parallax error. So sometimes the measured value will be smaller or bigger than the one that it's supposed to be. So it depends on where you're looking from. So this is why it's random. You can be looking from the right or you can be looking from the left. So it will affect the exact answer that you're supposed to get. Okay, so question, what happens if when you're making the measurements, you always place your eye on one side of the marking? So let's say from this diagram here, I'm always looking from the right. So what can you say? What kind of value will you get? If you're always looking from the right, Kenneth, what do you get?
if you're always looking from the right, is it?
Yeah, will it always be bigger or will it always be smaller? Okay, so what can you tell me in this case? The parallax error will become a systematic error. It won't be random anymore because you're always looking from one side. So be careful about parallax error. You must know which context it's applied to. Now, this one, how do you eliminate systematic error? So you must check first before using the instrument. If you see it's faulty, you just change it. Use one which is working fine. For random error, you can get rid of it by taking the mean. Because sometimes it's bigger, sometimes it's smaller than what it should be. So if you take the average, you will get a fairly accurate answer. That's why you must do average. And the second way of getting rid of random error would be to take a line of best fit if you're having a graphical method that you're using. So precision and accuracy, okay, the difference is that precision is how the values relate to each other. So it's about the number of SF or decimal places, whereas accuracy is how far is it from the true value. So let's say, look at this example here. I tell you that the exact value of G is 9.81. So the first set, can you tell me whether it's accurate or precise? 9.81, 9.83, 9.79. Okay, let me just finish this. So, Wei-Lin, what can you tell me? Is it accurate? 9.81, 9.83, 9.79. Are they close to the exact answer, 9.81? Yes, so it's accurate. Is it precise?
Precise.
Because the actual one is 3SF. Here, all the three values are also 3SF, so it should also be precise. Correct. Second one, everything is 3SF, so it's precise, but is it near the correct value? No, so it's not accurate but precise. And then you can check for yourself that the third one is accurate because it's 9.7, 9.8, it's near the correct value, but it's not precise because you're only having 2 SF. Whereas the fourth one, it's all not accurate and not precise because you're having 1 decimal place only. Yeah, so that's about it. So this diagram is just to illustrate the difference in terms of shooting dot at the ball. So yeah, that's about it. Okay, precision and accuracy.